Science is for those who want to know, and art is for those who already know. And I think anybody who spent time trying to do audio and video production has experienced the fact that there is both a science and a mathematical component to it, and kind of an art and a component which is not as well understood. It can take many, many years to even just start to grasp some of the concepts or some of the skill required to do a great job of audio and video production. And we're very fortunate today to be joined by at least one of two people that we expected to have here today. Darren Giles is the technical director at Terry Interactive, and Curtis Palmer is the CTO of Sonic Foundry, and we hope that he joins us here in a little bit. I'm Richard Saunders, and I'm a program manager at Microsoft in the Streaming Media Division, and I work on some of the tools in the platform group. Our objectives here today there's two of them. Learn the best practices involved with producing and delivering great streaming media content, and then to understand the key factors in creating great content for Windows audio and video using that technology. There'll be a couple of common themes throughout this talk. One is how you target the specific bandwidths, the bit rates for the users that you're trying to get at, and also the delivery mechanism. Briefly talk about real-time capture of content to the Windows Media format. I'll talk about delivery options. Then Darren's going to talk about creating great Windows Media video, and Curtis Palmer will talk about creating great Windows Media audio. If he shows otherwise, Darren's going to has graciously offered to take that portion as well. This is a map that you've seen several times today, talking about the audio or the authoring, the production, and then the actual playback of different content and how you can deliver it. The encoding workstation is the workstation which runs the Windows Media Encoder or an application which uses that automation interface, or an application built on top of the Windows Media Format SDK. It is in real time capturing audio and video off of the audio and video devices and encoding that directly into Windows Media, either as a file on disk or as distributing it in real time to a Windows Media server for further distribution and broadcast, or maybe even archive. The editing workstation is the offline production environment where audio and video is acquired or captured, is then edited and further processed, and eventually converted to and compressed to Windows Media. This is a much more time-intensive manual process and can be very expensive. And this is where Darren's going to focus his talk today. So once you have that content, there's several different ways of delivering it once you have a Windows Media file. There's a Windows Media server, which is really the best way to deliver streaming media content, as you've heard earlier in the day. It is a set of services designed specifically to deliver streaming media over a variety of network topologies and to a variety of users connected at different bandwidths. You can also deliver Windows Media via a web server, like Tom talked about. Now there are certainly features that you do not get when using a web server. It is not designed specifically to stream multimedia content. But if you're just getting your feet wet in streaming media, or your requirements are lower for streaming content, it's a good way to get your feet wet. Finally, download and play. You can host a Windows Media file on a web server to be downloaded onto and consumed from the local device, or it can also be transferred to a phone device or a music player, etc. So when we look at what I refer to as the encoding workstation and capturing directly to a Windows Media format in real time, there's probably three reasons why you'd want to do this. The first one is that your content is live. you are capturing from your event is live, or you're capturing in real time from a source which you want to distribute and broadcast over a network to your users. The second one is that you really don't have any editing requirements. The encoder or the tool that you're using to capture your content can be compressed and converted to Windows Media, and in that form, you don't have any additional requirements. The content is fine, you don't need to process the audio and video, and you don't need to do any real editing on that. And the third, which is related to the last one, is just time to air. From the time that the content is captured to when it has to be on the website for consumption is so tight that you simply cannot afford to do any sort of editing or processing on it. So looking at the encoder and encoding process running on this workstation, there's a couple things to consider. You heard earlier about the fact that the Windows Media Technologies is optimized for various features of AMD and Pentium processors. We can also scale up to multiple CPUs. For the Microsoft MPEG-4, we scale up to 4 CPUs. And for the Windows Media Audio, we scale up to 2. So if you're doing real-time capture of audio and video, the more powerful the system, the better quality you'll be able to achieve. Now, on audio only, the requirements are much lower than if you're doing video. For capture devices, standard things that we recommend are Sound Blaster 16 compatible, and the Sound Blaster Live is a good standard PC card. And the Osprey 100 is a device which has done very well in our tests. We actually support many different cards that support the video for Windows, but this one again has proven to be the best in our tests. As far as Windows Media and MPEG-4, internally that codec is the pixel format that it is architected around is IYUV. So if you have a video capture card, it is best to configure your system to capture that format from the device so there is no conversion that happens. That way you'll get the optimal performance. Lastly, on this box, you can have multiple encoder applications running. We have a system at Microsoft which has 4 Osprey 100 cards and a Gadget Labs multi-port sound device. And so we can have 4 different encoders running with different encoding profiles, perhaps to different bit rates, all using unique devices and distributing to unique locations. 2 other fairly big things that you need to be aware of when you're constructing your encoding profile is multi-bit rate decoding versus single stream. We heard earlier about intelligent streaming and all the quality aspects that it can deliver, that it can improve on playback for the end user. Well, multi-bit rate encoding is a feature of intelligent streaming which allows you to encode multiple video bands within a single Windows Media file or stream. I have 7 up here because there's actually an insurance band which is calculated off of the lowest video band and encoded into a stream if you're using the Windows Media encoder. And again, the idea of these multiple streams is that the Windows Media server, in communication with the client, will dynamically determine the appropriate video stream to send to the client. And it will also adjust during playback so that the data delivery is smooth for the player. If you are delivering from a web server or developing content for download and play, you're going to want to not use multiple bit rate encoding. There are 2 reasons for this. First of all, for streaming from a web server, the web server has no intelligence about these different video bands. So it will actually send all the bands simultaneously down to a player. And that will, of course, saturate a modem connection. And for download and play, although you can download a multiple bitrate file and play back the highest stream, it doesn't make sense to have the user have to download all that extra data. So just to kind of recap on the delivery options, the Windows Media Server is what's going to deliver your best quality. The capabilities you will not be able to get from any other type of service, live and multicast, those types of things, and scalability, the ability to scale to up to 4,000 on a single box, 4,000 connections on a single box. You get logging and content security, and also access to things like the server plugins, which enable things like pay-per-view and authentication. So you can stream from a web server. It's a good way to get started. You do lose, of course, all the intelligent streaming and delivery features available in the server, and you don't get things like seeking and fast forward, fast rewind. You do want to encode a single stream, and on a web server, you need to know that you have to set the MIME types on that server so that the client and that web server can stream. And it does actually stream. It doesn't download or progressively play. The player actually gets the data packets in a metered way and renders them as it receives them. And then as far as download and play, that is hosting a file and making it available for download directly from a web server. And of course, you want to encode that for a single stream. And the thing you need to realize, of course, if you have a file that you're making available for download that can then be uploaded to a device or further distributed, you may want to think about digital rights management and if that plays into your content creation process. So with that, I'll now turn it over to Darren from Terran Interactive to talk about video.
Thank you very much, Richard. We get asked an awful lot at Terran. Actually, we can see the slides here a little bit here. We get asked an awful lot. You guys work with a lot of video. What's the magic bullet? What's the one thing that I need to do to really, make my stuff look as good as some of the examples I've seen you do? Unfortunately, the answer is that there really is no magic bullet. There are, however, a number of steps which are pretty predictable and learnable, which if you really get up to speed on, you can start consistently turning out good results yourself. So let's talk about a couple of those today, and kind of how that ties into the whole process. The important thing to keep in mind is that this is an entire process. This isn't just one step. And so it's important to keep in mind the whole stage from video capture. There's some interesting things you need to do to clean up the video once you've captured it. And then how to set your various settings to get the best possible results. These all kind of work together. And one of the things that I'll mention is when you're working on a project, it's a real good idea to do all the way through. Go from start to finish with one piece of media, make sure it's really working for you properly. Don't shoot everything, then capture everything, then compress everything, then try to stream it all. Or you may go the way of one of our clients who had the unfortunate experience of making the mistake that a 28.8 modem was 28.8 kilobytes rather than bits. Produced everything about an order of magnitude too large, and spent 2 months before you did the first test actually to look at it on the modem. Follow some of the steps I'm talking about today and try it once all the way through before you do everything. You'll really be happy for it. So the first step is the video capture part of the process, where you're taking material that's existing on the tape or in some other format, and you need to get it into the computer in the first place so you can start the process towards getting it to a point you can actually deliver. There's a lot of different sources out there. These are some of the most common that are up on the screen here. The first category is Betacam type stuff, VHS. There's really a wide range, of course, of tape formats that are being used to store the media in the first place. And there's a number of issues that you'll run into with those. We run into really the issue that there's this easy assumption you can make, which is that the computer screen and the television screen, they're both CRTs. It's the same technology. It all works the same. And it really doesn't. And I'll show you a couple of reasons why that's different and how to get around it. An important point to make when working with material that comes off of tape is you always want to capture it full size, full frame rate, and use that as your starting point. Then there's a number of techniques you'll do, such as data releasing, I'll show you in a moment, to get the best results. That full size, full frame rate capture sometimes catches people off guard. You're thinking, well, I'm only going to deliver this stuff in a very small format. Why do I need to waste all that disk space capturing 4 times as many pixels as I want? And the reason is that the goal is to produce the best quality result out the back end that you can. And every single step in the process, you tend to lose quality. And if you start by throwing away 3/4 of your quality to begin with, you're never going to make it back up again. And there's some techniques that are very important you won't be able to do if you do that. So for beta, VHS, and those sorts of things, there's a couple of issues that are important. I'll show you in just a moment some examples. For DV material, very similar to traditional tape with a couple of important differences. One of the biggest ones is that DV tape includes the standard of progressive as well as the standard of interlaced video. And if you're shooting something that's specifically designed for streaming playback, the interlacing will work. It'll get you down to progressive you want to end up with, but it's not your ideal process. And you can start with progressive source to begin with. You'll actually have a pretty big advantage there. And then finally, film. An awful lot of material that's high quality content will originate on film, typically go through the video process before it goes to the computer, which means that a telecity has been applied, where the film at 24 frames a second is converted to 30 for video. And there's some techniques that are done there. The problem again is that it'll end up as interlaced video, and that's not really where you want to end up. So I'll show you how to get back to the original. And then also the letterbox borders. So the point of this basically is any type of source you're working with is going to have different issues you need to be aware of that you need to kind of correct for to get back to what the pristine original essentially is in a format that will work well for compression. So enough handwave, I'll actually show you some examples of what this all looks like. We can go back to the samples machine here. So the first example, I'll bring up something that was shot. This is fairly typical material that's original video shot, in this case I believe on a Betacam deck. The thing we're looking at here, the single biggest issue is it's a nice big source. We've got a whole lot of pixels to work with. We can do a lot of things to take advantage of the quality of the source. What we may not see as well on the big screen is that this material is interlaced. I'll show you an example which gives a little better kind of a close-up, and this will actually be from a different piece that shows what the issue is. And this one you should be able to see a little more readily. As you move through the material, you get this kind of a horizontal cone striping effect. If you look at much video, you've seen an awful lot of this. The problem is that this stuff looks great on the television, it looks horrible on a computer. You don't notice these things if you're looking at this on a television monitor, but if you're doing streaming video, you're not going to deliver it on a television monitor. At least that's certainly not your main objective. And also, most of the streaming technologies are not well optimized for interlaced video. So when you play it back, not only will you get the kind of strange kind of banding effects you're seeing here, but it also won't compress as well. So the overall quality will be even lower than that. What you want to do in that case is to apply what's known as the interlace. And essentially, we're taking the same material we had before. We do a process that removes the interlacing artifacts, and now we're down to something where that weird horizontal stripage is gone away from us. So that's a real important step. Anytime you're working with stuff that's interlaced to begin with, we'll go back to our full resolution source here, you need to get rid of that effect if you're going to get the best possible results. There's a few other steps we'll do as well. Those are kind of common across all the formats. Let's do those last. Specific to DV, again, I mentioned using progressive scans as being a real important option. Actually, this paper machine I'm using is software approximation to show the DV stuff be quite as clear. But the same issue applies. Film's a little more complicated. With film, you're running into an issue, as we mentioned, called telecity. And I'll pull up an example here. The issue with telecity is that the film starts again at 24 frames a second. It's converted to 30 frames a second to look at on the television screen. And now what we need to do is basically throw away those extra frames and get rid of the interlacing that shows up, because if you step through something that's shot on film and transferred to video, you get a couple of frames that look fine. There's 3 frames that look fine. And then a frame there, which again, suddenly we have this very, very obvious interlacing artifact that shows up. You'll see 2 bad frames, or interlaced frames, 3 good frames, 2 bad. If you see this pattern, you're working with stuff that's started on film. And ironically, because film material is typically the highest production qualities and the most valuable material, it's quite ironic that a lot of material shot on film isn't properly treated and ends up looking worse than if it had been shot on video. So there are things you can do to take care of that. That process is called inverse telecity, or it's also known as 3-2 pull-down removal. There's a couple of things to be aware of when you're doing this. Again, look for the pattern of 3 good frames, 2 bad frames. Use a tool that allows you to do inverse telecity. There's a lot of tools out there that will do this. The tool I'm showing you today, and my bias is pretty obvious because it's our tool, is Media Cleaner Pro. There are a number of other tools that will do this as well. One of the things that's nice about Media Cleaner, though, is it deals with an issue which is in a complex world known as phase change around every edit point that you have. In a simpler mode, it basically says every time you come to an edit point, this may change. With a lot of systems out there, you have to manually guide it through that. Media Cleaner will just automatically take your material and just do the right thing. So again, you want to get it from what I just showed you to one which has got the telecity issue removed, and now we're down to this one here, and you'll see every frame looks solid. In addition to that, we have fewer frames. We've gone back to the 24 frames of our original. Fewer frames of redundant data is a good thing, because it's less data that needs to be compressed, less data that needs to be transmitted, it'll give you better results. So it's real important to be aware of. Another issue which you'll also run into in film, and this particular example doesn't have it, is you'll have letterbox borders around your material an awful lot of the time. And typically video is full frame, as this is. Film often will only have the center portion of it show up widescreen that's actually used. And as we'll go into in a moment, one of the things to be aware of when you're doing streaming video is you're not limited to 4:3 aspect. You're not limited to any specific one, but you do want to get rid of that extra area. I'll show you how to do that. Okay, so you've thought about some of the issues involved with your source video, and you've captured it, put it into the computer, and now what exactly do you need to do to take this and clean it up properly? And I'll show you just an example here. Where here's a pretty typical capture. This is some film source, and it looks pretty good. You will notice, if you can see it on that particular monitor, the 3:2 pattern that's typical of telecity. But basically, we think it looks pretty good. So now we want to take this and optimize it, and I'll show you that even though you think it's pretty good, there's actually still a fair ways you can go yet. What I'm going to do now is show a couple of features. Again, these are going to be done through Media Cleaner. One of the nice things about Cleaner is it's possible to do all these in one tool. It often takes a combination of other tools to get to the same place. And what I'll do is I'll pick one of my presets that comes with it. This has all the settings that are involved. You can pick this as the preset, you can hit start, you'll get very good results. But the point of this section is to figure out how to get the best results and really go to the next step beyond that. And specifically, I'm going to do a couple of things that I talked to you about here. So we'll go to the image section. We'll choose deinterlace. And we'll tell it that we want to do a telecity or a blend, depending on what material we work with is. Just to make this a little clearer for this demonstration, I'll do it that way. So again, we're either deinterlacing or telecity as appropriate. And then we can get a little preview here and see what that looks like. I'll make my image size a little larger so it's clear what I'm doing. One of the things that Cleaner does, which is kind of nice, is give you this little preview window so you can kind of see what impact your changes are having. And now one of the things you'll notice here is that we have this strange kind of ghosting that's going on, this doubling that's happening in our original on the left-hand side. And as I went this through, you'll see the difference where we've now removed all those ghosts and everything now is just a single image that shows up. So that's kind of a step in the right direction. So that's one of the first things, is to get rid of that doubling, the extra lines that show up from your telecity or your interlace. Another thing that's typically very important, this one catches a lot of people off guard, is, as I mentioned, televisions and computers don't really work the same on a technical level, in terms of there's a lot of differences in things like the range of colors you can represent. And if you're familiar with the video standard, you can't go all the way down to true black, because that's actually technically an illegal color to use. You have a more limited range of colors that can be represented. So one of the things you want to do is deal with the fact that you're moving the stuff over to the computer. You've got a bigger range that can be displayed. How do you take advantage of that? And one step, it's a pretty simple one, but a pretty good step in the right direction. You'll see me doing here. We just boost the contrast. Real easy to do. And now we're with something where we thought it looked pretty good, but now you'll notice doing this little kind of before-after little wipe effect here. You'll notice that it gets a lot more vibrant, in addition to that doubling going away. This is really better suited for computer display than it had previously been. You can also, in some cases, don't want to boost the saturation or do other things. Those are kind of do it to taste. Again, you can do this all in the same place. And then finally, one other one that you'll notice here is, I'm not sure how clear it'll be up there. You should be able to see it. There's a little bit of a black line that runs down the edge of the image right now. And what we're seeing here, again, is the difference between traditional video and computer video, which is something that's designed to be shown on a television set, has the concept of an overscan. There's kind of the safe area. You know you'll see the stuff in this area. And there's kind of this little fuzzy area you may or may not see, and you definitely won't see stuff outside this. So anytime you capture something that was originally developed for television, you'll typically see that little black overscan region around it. Computers, of course, don't have this concept, and certainly not when you're playing material in the window. But it amazes me how often I'll see material that's delivered on a website, and especially if it's on a white background, and you've got this little black border that runs all the way around the edge of it. It's kind of uneven, and it changes from scene to scene. Just not really a professional way to do it. So the message here is always make sure to crop off that overscan region from the original. Now, in Clear, it's just a matter of clicking and dragging. They're now specified, okay, I want to get rid of that. It was constrained, so I don't have to get the right amount. And now you'll notice, if you look closely, that when I do my new preview, one second here. Oops. Make sure this is set up right. No. I haven't properly appeased the demo gods today. There we go. There we go. So what you're seeing here is that I've gone ahead and now gotten rid of that little black area that was originally around the image, and that will give us a much better result in the final product. So there's a lot of things you can do to clean up your image that will give you better results. Another one that's important, I'm not going to try to show it on this one here because it's just not going to be too clear with the resolution of the projection screen, but you want to go ahead and sit back to the slides at this point. You want to go ahead and deal with an issue, which is the fact that your original video material will typically have noise in it. If you look at a still frame of video very closely on a high-quality monitor, you don't see smooth areas. You see a little bit of blurring that goes on, or a little bit of speckling that shows up, and these weird little things you would expect to be there. And again, if we can go back to the slides. So in addition to doing the other steps that we talked about, you also want to make sure to go through and do what's known as the noise reduction pass. And this is video noise, not audio noise. I'm talking about the same concepts apply. What this does then is it'll go through and say, okay, these areas that were supposed to be a solid blue background, but it's really got this little bit of speckling that's involved. Let's make it solid blue. It'll look better, it'll compress better, it'll give you good results. If you've been working with digital video for a long time, a step that's often talked about is applying a blur to the material to get better results. And you can use a blur, but not surprisingly, that'll blur your image. So one of the things you want to do instead is take advantage of features like an adaptive noise reduction technique, such as is built in the media player, that will give you the advantages of doing that noise reduction without blurring all the images that you're working with. Okay, again, no silver bullets, but I do want to talk about kind of a couple of things regarding the settings and how to best optimize them. You can start with the presets. We've got some pretty good ones as a starting point. I'll be showing you in just a moment, again, a good set of guidelines for where to start with. That's your starting point. You then take it and tweak it from there for your specific application as much as you can. But there's three areas that are pretty key to the whole thing. One of those is the image size. And the trade-off between the larger, you can make your image as large as you want, but the larger you make it, you're not going to have as much room for frame rate. You either use the data to represent bigger images or more of them, so that's kind of one trade-off. And keep in mind, again, it doesn't have to be 4:3 aspect. We've seen some great movies that are delivered that are widescreen movie trailers. They look great delivered that way. The frame rate, another real important point. Your frame rate should be an even divisor of your source. You don't want to take something shot at 30 frames a second and deliver it at 12. Because what happens is, since that doesn't divide evenly, you'll skip a frame, play a frame, skip a frame, play a frame, skip 2 frames, play a frame. It looks kind of jerky. So keep in mind what your source started from. And if it's NTSC, go from 30 down to 15, 10, 7.5 is just fine, doesn't have to be a whole number, etc. PAL starts at 25, so the numbers there are a little bit different. And film starts at 24, so the numbers there are a little bit different. Again, don't take film that starts at 24 and take it down to 15. That will be a real good step in the right direction. And then data rate, as I mentioned earlier, don't make the mistake of thinking a 28.8 modem is 28K bytes, is 28K bits. And also don't make the mistake of thinking you get to use all of those bits. You only get about 10% of them. I'm sorry, typically about 80% of them. Then another trade-off that's related is video quality. Again, it's trading off. You can have sharper looking frames, but you're not going to have as many of them. You'll kind of spend the bits that it has on a smaller number of frames. And Richard's already talked a fair amount about intelligent streaming, so I won't duplicate that. One last thing I'd like to show you, again, this is all kind of a high-level contextual background for you. A lot more information is available at the Terran Interactive website and at the Microsoft website as well. And then finally, again, a good set of starting points. Use these as your basis, and you'll be off to a great start, and you'll want to tweak it for your specific application. So that's kind of a background and introduction to what the process looks like. Again, I recommend look at a lot of media, look at stuff that's done well, learn from it. There are people out there doing a great job, and we're all still learning how this goes. So keep experimenting, and it'll be great results. Thank you.
Okay, so as I mentioned at the beginning, we had originally planned for Curtis Palmer from Sonic Foundry to talk. He has been delayed, so Darren has gracefully offered to cover that portion as well. And hopefully this isn't a sign of Darren acquiring Sonic or something like that.
Yeah, we talked a lot about video, but of course the audio side is equally important. So as I mentioned with the video side, there's a lot of different tools out there to do this. Obviously, again, I'm going to be talking a bit more about media players since that's what I'm specifically familiar with. Sonic makes some good audio tools as well. In general, the practices are fairly similar. The issues are fairly similar. It's a matter of looking at your process from start to finish and not just concentrating on any one phase and saying by really doing that well that everything else doesn't matter, because that's definitely not true. So again, you start with input. One of the things that is safe to say here is that you always want to work with full range input. You know, there's no reason to do anything other than either 44 or 48 kilohertz, depending on your source is. There's no reason to ever do anything other than 16-bit. I've actually seen some 8-bit stuff being used recently, and that's 5 years out of date. That's just horrible. And you know, again, work with high quality inputs. It will make a difference. Don't go into this assuming that it's not going to sound good coming out. It doesn't have to sound good coming in. It can sound good coming out. Noise removal, just as in video, very important in audio as well. When you're working your material, you're going to want to make sure to remove any noise that happens to be there in the original, because your goal is to have a nice clean signal that's compressed in order to get the best results out the back end. There's a number of different ways to do noise removal. Again, Sonic has some great tools to do it. Media Cleaner actually has audio noise reduction built into that as well. And then another one that's important to be aware of is dynamic range. And dynamic range is essentially the difference between the quietest and the loudest sounds in your material. The traditional example is classical music tends to have a very broad dynamic range, from the really quiet little single instrument playing to the whole orchestra going. And one of the things you'll tend to find is that material is designed to be played back on a high fidelity system may not sound as good on computer speakers, so that's one reason to be a little more cautious about dynamic range. And also that a number of codecs don't like compressing quite as wide a dynamic range, because they're trying to, when you're trying to take material and squeeze it down by a factor of 20, you have to make some trade-offs. And so that's the one to be aware of. Let's see. Since I'm not working on my own notes, I apologize if I'm not speaking totally to these, but I'll dive into a couple specifics now. Input guidelines, again, we talked about this briefly, but use high-quality material. Get a good sound card, that goes without saying. Again, 44 kilohertz or 48 if you're working with some sources that's the native. The message basically is work with whatever your source looks like. 16 bits are better, absolutely true. And again, just all throughout the process, use good components. Good microphones, speakers, mixers, the whole works. The audio levels is what I want to touch on briefly. It's really easy to keep cranking something up because there's a natural tendency to think the louder something is, the better it sounds. And you can go too high. The one clear issue is if you run into clipping because your material goes so high that you've exceeded the range that you can represent. That's bad. But the other thing we found is if you get it too hot, again, the codecs don't tend to like that a lot. So one of the things you want to do to deal with that, it's often useful in this normalization, where you want to take all your material and make sure that the peaks aren't too high. And typically we find like, in media cleaners measured in percentages, because older folks haven't done as much background in audio, and decibels are a little bit tricky, but it's the same basic concept. You want to take your material and go to Cleaner here, I'll go to the audio section. We already gave the video section of Cleaner before. Again, there's a lot of audio features. So for example, here's a noise removal. We've got a couple of presets. Here's a dynamic range. We can make a number of changes there. And then you can basically go through and say, I want this not to go all the way to full scale, but get me within a reasonable range of it. Finally, the normalize that I mentioned. So this is a pretty good set of settings for Media Player to work on audio. It depends a lot on your material, what it is you're trying to do with it as well. Again, one of the nice things with doing solid clear, we have very strong batch processing in the Pro version. So, for example, you can see here I've got a list of a whole bunch of different sources, DV and film, and a bunch of other things. You can literally drag a few hundred sources or even a couple of thousand into the batch, set up your presets, and automatically go through everything and give you good results coming out the back end. And being able to do audio and video together is pretty important. Back to the slides, I guess we can. Again, avoid noise in the first place, absolutely important. Avoid some of the more common problems. Having a noisy environment makes a heck of a difference. One of the ones I'll mention in addition to what's mentioned here is computers are fairly noisy. The fan in your computers is pretty loud. If you tape anything with a computer in there, you're likely to hear it. So a whole lot of different sources of noise. Minimize them. Your goal is again to have a clean signal coming out. We've already talked about dynamic pressure normalizing. The recommendation that's made here is normalized to about -1.5 dB. Kind of a personal preference. I typically recommend -2. It's very similar. Again, there's two reasons you normalize: to avoid getting too loud at any one point, and then also kind of bring the whole range of material to a similar level. That'll give you some pretty good results too. Bunch of Sonic Foundry tools and some guidelines. Didn't ignore the tools. I should point out, these are all great tools. Some of them are more relevant to the talk here today than others. The audio guidelines, again, just as with the video, there's a lot of good starting point guidelines. Consider them a starting point. Don't take them religiously. Try it and see what works for you. One of the really cool things about audio on the internet is video, especially in a model where you're working with low bitrate modems and home users, can be stretching it a little bit. You can do some really good things with video, and Windows Media's implementation of low bitrate video is excellent. The MPEG-4 cutter gives you brilliant results at low bit rates. But let's still keep in mind, it's the difference between is it this big or is it this big, and is it you don't want to watch or is it okay to watch. As you get up to higher bit rates, it gets better and better to watch, and it gets really exciting. But keep in mind what it is that you're doing. A good example of that is music videos. I've seen an awful lot of 28 music videos out there, and I just can't imagine wanting to watch one start to finish. You get into broadband, it gets pretty exciting. But if you're really going to listen to something on a 28 modem, you may be better off just doing audio only. There's a lot of cases where that makes a lot of sense. And there's some really cool things that are being done, if I can move to the middle machine, with regards to audio-only applications of the Windows Media technologies. A good example is basically internet or web radio stations. And the technologies have a very good fit there. If I move to the middle machine, I'll give this a try.
Call 1-800-USA.
Of course, the downside of internet radio is you get ads with it as well. What you're doing right now is, there we go. This is an example of the launch website which uses this technology. And I'm now looking at a 56K delivery. Again, this is a live radio, there's a little bit of a questionable here at any given instant. But the point is, you can make some very effective presentations that are audio only. And even if you're doing video presentations, don't neglect your audio, because in order to make your video, it literally is look better to have a high quality audio there. There have been some interesting studies that have shown that the audio quality of your presentation literally makes people think that the video is better. The two go very much hand in hand. So again, some good starting points here. I recommend for more information, try it yourself. Look at what other people are doing. Look at the Windows Media website, and look at the Terran website, www.terran.com, for a lot more in-depth techniques. The tool that I've been showing here mainly today is Media Player Pro. There's also a free version, which is the Media Player Easy for Windows Media Technology. You can get that for free off of the Microsoft website. Thank you very much.
Thanks, Darren. Thank you very much for doing the audio session as well. Here are the pointers to more information, and certainly you can find about solution providers and tools and ISVs under the Windows Media website. And for a lot of the delivery type of information, go to the MSDN Windows Media site. There's a lot of good technical articles up there.